Today, we're going on a journey into quantum mechanics.
Always a fun trip.
We're diving into this paper by Leonardo Chiodi.
Oh, this one's a real head-scratcher.
He's got this idea that the wave function is all about information.
Yeah, it flips the script on how we usually think about quantum mechanics.
It definitely challenges some basic assumptions about reality.
For sure. Get ready to have your mind bent a little.
So Chiodi's saying the wave function isn't just some math tool
It's more like a blueprint.
encoded with information.
Two kinds of information, actually.
Okay, I'm intrigued. Two kinds.
Yeah, so the first one, it's all about location.
So like a quantum GPS.
In a way, but instead of a single point.
It gives you a range of possible spots.
Exactly. It's the probability of finding a particle in a specific place.
And that's tied to the wave function's amplitude.
Right. The bigger the amplitude, the higher the probability.
So things get interesting because Chiodi says a particle doesn't actually have a location.
Not until it interacts with something.
So it's not like a tiny marble just zipping around.
Yep, more like a wave of possibilities.
Okay, so then where is it if it doesn't have a location?
That's where the second type of information comes in.
The second type?
Yeah, and this one's all about the particle's existence.
Its existence. I don't think I've ever thought about a particle existing like that.
It's a bit of a mind bender. It's how the particle persists over time.
So it's less about where it is and more about what it is.
You got it. It's a bundle of properties like momentum and spin that define it,
Existing outside of space as we usually imagine it.
right? And this second type of information keeps those properties consistent.
Even though the particle itself is spread out as a wave.
Exactly. It's like the particle is carrying a set of instructions with it.
A set of instructions.
Yeah, about how to be a particle, even without a fixed address in space.
But at some point it has to become an actual thing, right? Something we can observe.
Of course. And that's where Chiodi introduces this idea of a quantum jump.
A quantum jump, like it suddenly leaps into existence.
Not exactly. Imagine the particle spread out across all its possible states.
A wave of potential.
Right. And then suddenly it interacts with something else.
That interaction, does it force the particle to choose a location?
It's less of a choice and more of a focusing.
Focusing.
Yeah, all those possibilities collapse down to one point,
So the interaction provides new information,
and that causes the wave function to collapse.
not in a physical way.
Right,
Yep.
more like an informational collapse.
So it's not about things breaking apart, it's about possibilities narrowing down.
Exactly. The particle goes from being a maybe here, maybe there wave to a definitely here particle.
That makes sense. But how can something exist without a position in the first place? Where is it if it's not somewhere?
Well, that's where configuration space comes in.
Configuration space, another new term.
Yeah, it's not physical space. It's more like a map of all the possible states a particle can have.
So instead of picturing the particle like a tiny dot, we should imagine it spread out across this space of possibilities.
Precisely. It's a wave existing in this configuration space, representing all its potential states.
Okay, I think I'm getting that. But how does all this translate to how particles actually behave?
That's where we have to introduce something called the quantum potential.
The quantum potential, is that like a force?
In a way, but it's unlike anything in classical physics.
And Chiodi connects this quantum potential to the two types of information we talked about.
Exactly. It's as if the particle's potential locations and its fundamental properties are working together to guide its movements.
So it's like a cosmic dance choreographed by this quantum potential.
It's a good analogy. And to see how this works in practice, we have to look at the double slit experiment.
Ah, the double slit experiment. Always a favorite.
Classic quantum weirdness. Particles passing through two slits create that interference pattern.
Yeah, even if you send them one at a time.
It makes you question reality, right?
Definitely. So how does the quantum potential explain that?
Well, think of the potential as a landscape
Okay, a landscape.
with peaks and valleys. Higher peaks where the wave function's amplitude is low.
And lower valleys where it's high.
Exactly. The particles are drawn to those valleys, the areas of lower potential.
And those create the bright fringes in the pattern.
Right. It's as if the particle is feeling out all its possible paths guided by this landscape.
I'm trying to picture, it's like the quantum potential is shaping the probability of where the particle ends up.
Exactly. And that's how we get those alternating bands of light and dark.
This is so wild.
I know, it's a lot to wrap your head around.
Maybe we should take a moment to process all this.
Yeah, we've covered a lot of ground already.
We've just scratched the surface of what this all means for our understanding of reality.
There's so much more to explore.
Let's dive back in soon and see where this rabbit hole leads.
Sounds like a plan.
All right, so we've laid out this framework, Arctic. Particles are more like waves of possibilities.
guided by this mysterious quantum potential.
Existing in this configuration space.
Yeah, it's wild stuff.
But what does it all actually mean? Like, for our everyday reality?
That's the million-dollar question, isn't it?
It feels like we're not just getting new
It's
equations.
a whole new way of thinking about reality.
Chiari's suggesting that information isn't just about the quantum world.
It might actually be the foundation of it.
Okay, so instead of a universe made of tiny particles...
We're talking about a universe built from information.
Whoa.
Yeah, it's a pretty radical shift in perspective.
It makes me think about that electron in a hydrogen atom.
Ah, yeah, good example.
If it had a fixed position like we usually picture,
It would create an electric dipole moment.
which we don't actually observe,
Right, so Chiari's model isn't just some abstract theory.
it actually explains what we see in experiments.
Exactly, and it gives us a way to understand why particles don't have a defined location until they interact.
So they're like this spread out potential, this collection of maybes.
And then when they interact, boom!
It all collapses down to a single point
It's like the universe is constantly calculating, processing information.
to decide what becomes real, what actually happens.
That's a really poetic way to put it. I like that.
But it raises some big questions about time and causality.
Oh, yeah, definitely.
If particles are packets of information, does that mean they exist outside of time as we experience it?
That's a tough one.
And what even triggers those quantum jumps? What makes a possibility become an actual event in our reality?
Those are questions philosophers and physicists have been wrestling with for centuries.
Maybe the universe is just one giant quantum computer.
It's a tempting analogy, right?
If particles are like bits of information,
And interactions are computations.
the whole universe starts to look like an information processing system.
It kind of makes you wonder where all this information comes from in the first place.
And what does it even mean to say that information is fundamental?
Yeah, that's getting into some deep philosophical territory.
Well, our brains might be hurting a little bit, but let's keep pushing.
We can handle it.
We've been talking about single particles, but what about larger systems?
Like atoms, molecules, even us.
Yeah, how does this information idea scale up?
That's where things get really complex.
I bet.
Remember configuration space. For a system of multiple particles, that space explodes in size.
So instead of a simple map, it's like this multi-dimensional maze,
Exactly. And the quantum potential is guiding the whole system through this maze,
shaping how the particles interact with each other.
leading to the emergence of those larger structures and behaviors we observe,
It's pretty amazing to think about it all happening on such a tiny scale.
but giving rise to all the diversity and complexity we see around us.
Yeah, it really makes you appreciate the power of this framework.
By understanding systems as networks of information, we might be able to unlock all sorts of new insights.
Like into chemical reactions, biological processes.
Maybe even how the brain works.
It makes me wonder if there's like a resolution limit to reality.
A resolution limit.
Yeah, like if everything is ultimately information, is there a point where we just can't zoom in any further?
Like the pixels get too small.
Exactly. Maybe reality itself gets blurry beyond a certain point.
That's a fascinating thought.
It's like asking if there's a fundamental limit to the information the universe can hold.
Or if there are some mysteries that will always be beyond our grasp.
Makes you feel pretty small, doesn't it?
In a good way, I think. It's a reminder that there's always more to learn, more to discover.
That's what makes this all so exciting.
It's a never-ending adventure.
And speaking of adventure, this information-based view might have some very practical implications.
Oh, absolutely.
Like in the field of quantum computing.
Huge potential there.
Could we use this understanding of the quantum potential to design new algorithms?
Or build entirely new types of quantum devices.
Who knows what we could accomplish if we crack the code of this information processing system?
The possibilities are really endless.
It's amazing to think that these abstract ideas could lead to some pretty revolutionary technology.
That's the beauty of science.
Sometimes the most fundamental discoveries lead to the most unexpected advancements.
And Chiari's work, by reframing quantum mechanics in terms of information, really opens up a whole new world of possibilities.
It's like we've been given a brand new set of tools.
And we're just starting to figure out how to use them.
Our brains are definitely getting a workout today.
A good workout, though.
But before we get too carried away,
Yeah, there's one more crucial aspect we need to talk about.
we've covered particles, information, the universe as a computer.
But what about us?
What about consciousness, our experience of being human?
Those are the big questions, aren't they?
Does this information-centric view have anything to say about those things?
Well, Chiari's work doesn't offer all the answers,
Of course not.
but it does give us a new way to approach these age-old questions.
So how does it change the way we think about consciousness?
Well, imagine our brains as these incredibly intricate networks of information processing.
Okay, I'm picturing
And some theories propose that consciousness arises from the complex interactions within those networks.
almost like a biological quantum computer.
Exactly. Our brains constantly processing and integrating information from the world around us.
And from that emerges this subjective experience we call consciousness.
It's a fascinating idea.
So instead of seeing consciousness as separate from the material world,
It could be an emergent property of this information processing.
and that brings us to another big question: free will.
Ah, yes, the age-old debate.
If everything is ultimately information, does that mean our choices are predetermined?
It's a tough one. Some physicists say a deterministic universe means free will is an illusion.
But others argue that quantum randomness could provide some wiggle room for genuine choice.
So the mystery remains.
Are we puppets of fate, or are we truly in control of our destinies?
It's a question that might be beyond the reach of science to definitively answer.
But it doesn't make it any less interesting to think about.
Exactly. It's these kinds of questions that keep us pushing the boundaries of what we know.
And what it means to be human.
Absolutely.
Well, I think we've reached the limits of our philosophical pondering for today.
Our brains have definitely had a workout.
But any final thoughts before we wrap up this deep dive into Chiati's work?
Just that it's a powerful reminder that the universe is far stranger and more wondrous than we can possibly imagine.
And that's a beautiful thought to end on. It's like we've stumbled into this whole new way of understanding reality.
And we're just starting to make sense of it.
Who knows what we'll find as we delve deeper into this idea of information as the foundation of everything.
That's what's so exciting about it. There's so much potential for new discoveries.
It makes me wonder if we could take this even further.
Further.
Yeah, like we've been talking about how information shapes the universe.
Right?
But could it work the other way around? Could we actually imprint information onto reality?
Whoa, that's a big idea.
Like imagine being able to manipulate reality with our minds.
It sounds like science fiction, but who knows?
It might not be as far-fetched as we think.
True. Think about quantum entanglement.
That spooky action at a distance thing.
Exactly. Two particles linked together no matter how far apart they are.
Some physicists believe we could use that connection to transmit information instantly.
Faster than light.
Now, that would be revolutionary, if we could actually do that.
It would change everything. Communication, our understanding of the universe,
The possibilities are mind-boggling.
all stemming from this idea that information is fundamental.
Which brings me back to those big philosophical questions.
Oh yeah, the ones that never go away.
If information really is the building block of reality,
Then what does that mean for consciousness? For free will?
are those just information patterns too?
It's hard to say for sure.
Chiati's work doesn't pretend to have all the answers.
But it gives us a new framework to think about these things.
So how does this change the way we approach something like consciousness?
Well, picture the brain as a vast network of information processing.
Okay.
And some theories propose that consciousness emerges from the interactions within that network.
So it's not some separate mystical thing,
It could be a natural outcome of all that information processing.
like a biological quantum computer.
Exactly. Constantly taking in information, making connections, creating this experience we call consciousness.
But then that leads to the question of free will.
Right, if everything is ultimately governed by information.
Does that leave any room for genuine choice?
It's a tough one. Some physicists argue that a deterministic universe means free will is an illusion.
But others say quantum randomness could provide the space for genuine agency.
It's a debate that might never be fully settled.
So we're left with this mystery. Are we really making choices?
Or are we just playing out a script that's already written?
It's a question that takes us to the very heart of what it means to be human.
And it's one that we might never have a definitive answer to.
But that's part of what makes this all so fascinating.
It's a constant reminder that there's always more to explore, more to understand.
Well, I think we've reached the end of our deep dive for today.
Our brains need a rest.
But before we go, any final thoughts on this incredible journey we've taken?
Just this. Chiati's work has shown us a universe that is far richer and stranger than we ever imagined.
A universe where information might be the key to unlocking some of its deepest mysteries.
And where the very act of observation plays a role in shaping reality.
It's a universe that is brimming with possibilities, and I can't wait to see what we discover next. To all our listeners out there, thank you for joining us on this deep dive.
Keep questioning, keep exploring, and keep that curiosity alive.
Until next time, stay curious.